Next up, I'd like to invite Jason Panyang to the stage. Coming all the way from China, from Horizon Robotics, to talk about AI edge computing.
Thank you, Michael. Good afternoon, everyone. My name is Jason Panyang. I'm a vice president at Horizon Robotics, focusing on corporate strategy and corporate finance. Horizon Robotics is a edge AI company. We focus on edge AI computing. We specialize in autonomous driving, smart retail, and smart city surveillance. So we are the first. We developed, taped out, and commercialized the first AI ASIC in China for AI computing, for AI edge computing. We consider our mission to be establishing a edge AI platform to make human life safer and better. Platform here means our solution is based on a full stack solution, which is semi-open to developers and OEMs who can customize their system based on our processors. So we aim to build the brain for all robotic forms, i.e., the perception, analysis, and decision-making devices embedded in all the edges. To do that, we are actually taking a step back. So today, most of the AI computation power only exists on the cloud, in IDCs. And it's almost a consensus now that these computing requirements will evolve, will come down from the cloud to edge. However, before that actually happens, processing power, energy efficiency, and cost efficiencies are three barriers to cross. So, taking an example for autonomous driving car, an L4 autonomous driving car generates 4 to 5 terabits of calculation requirement per hour. It's a very challenging environment, and it requires the highest standard in terms of functional safety, in terms of no latency, in terms of overall electronic stability. This is probably the highest standard that people can imagine in day-to-day life, in non-military usage case. However, if a calculation power need to come down from the cloud, first of all, the performance, the result cannot be compromised, and the latency need to be shortened, and the accuracy need to improve, because inaccuracy simply causes car accident, human lives. At the same time, even few people know that power efficiency and energy efficiency is another boundary. Is another barrier for autonomous driving car, because cars are big, cars are bulky, and any MCU or ECU with over 100-watt processing energy consumption will pose significant risk to the electronic system in a car. The stability and safety of a car will be endangered in that case. So how to address, and also how not to mention the cost efficiency, because IoT devices, edge computing are designed for mass deployment. How to address these key pain points become key for edge AI. Our solution is, on the left-hand side, we combine the superior AI algorithm designed in-house by world-class scientists And we use that algorithm to design hardware and processing unit that is highly and deeply integrated with the software so that it runs most efficiently. In that case, it is a full stack solution from a processor to firmware to algorithm and software, and the whole platform. It is semi-open, and also it can achieve around 1,000 times efficiency improvement versus traditional approach like CPU and GPU for general CNN inferencing tasks. We use that technology. We apply to autonomous driving, smart city solutions like video surveillance, where China has now become the largest market in the world, and also smart retail to convert offline data into online data that you can analyze. Let me go to more detail. But does it work? We were established 2 years ago. Once we bring up this, when we brought up this concept, we have few believers. But then it came the famous AlphaGo. I assume everyone here knows AlphaGo, but AlphaGo has been through a revolutionary path on its performance, on its calculation results, generation by generation, over the last 3 years, from normal professional Go players to Mr. Lee Sedol, the Korean champion, and also the Chinese champion Jie last year. As the calculation power and as the performance improves, few people notice that behind the improvement, the calculation power actually, which is the AlphaGo model, what AlphaGo model relies on, has significantly reduced, even more significantly than the improvement of the result. Let me take you into it. In 2015 October, the AlphaGo Fun version, we're talking about the whole room of servers, GPU servers, with hundred thousands of watt in terms of power consumption, versus a human brain, which normally takes 20 to 30 watt. It's not fair, but that's the case. And then AlphaGo Lee, that's right before Google launched their TPU. And then after TPU was fully launched in 2016, in the middle of 2016, the famous AlphaGo master that beat the world champion, Mr. Ke, is only run on 4 TPUs from the whole room of server. What makes it so powerful? The trick, or the secret, is the TPU itself. TPU is an initial for tensor processing unit. It's a calculation. It's a deep learning training board processor that Google launched in its Google I/O 2 years ago. It is designed and integrated with its open platform training platform called the TensorFlow. And the power comes from the deeply integration from bottom, from fundamentally, and that's the result it can achieve. So basically, from that end, human being, taking a historic view, human being has been through a long process searching for best hardware architecture for AI computing, from CPU to GPU, FPGA, and finally ASIC. Google Google Horizon Robotics and the software hardware integration is obviously right now on the forefront. Besides Google, so basically the TPU story, thanks to the AlphaGo performance, Google TPU is primarily on the cloud for training purposes, less for inferencing. Alongside Google is Horizon Robotics. Horizon designed its BPU, i.e. Brain Processing Unit. We started in 2 years ago, and we taped out last December. And it's highly compatible with the Hugo platform that is our open platform for autonomous driving, right? So basically, Google is on the cloud, Horizon Robotics on the edge. And this is basically where we are today. We taped out the first ASIC in China. We have international recognition, funded in 2015. Right now with around 600 employees and more than 120 patents, mostly hardware patents. And since inception, we consider ourselves a true innovator, because by the time when we start socializing the idea of software plus hardware approach to solve the edge AI pain points, guess what? We have very few believers. Until Google's AlphaGo story and TPU story, this concept became more popular, right? And we consider by the time we established, we have our ideas and PowerPoints. By December last year, we successfully launched our first generation processors. That's really how we convert our concept on PPT to processors. And along the way, we also started the development of our second generation BPU to dig into the ground, building up more barriers, and as well as we started commercialization of our product into the market that I mentioned, from autonomous driving to video surveillance and smart retail. Along the way, these are the few believers we had: Morningstar, Hillhouse, Sequoia, GSR, Eurominer. Mr. Eurominer is who is the founder of DST Capital. Came in our seed funding, and in our latest Series A+ funding last year, closed out last year, Intel joined the league. Intel was one of the most closed strategic partner we had, and we're only able to achieve that because of our solid and deep technology foundation. Dr. Kai Yu, in the middle, is the founder and CEO of the company. He's one of the earliest expert and pioneer in the machine learning industry in the world. He used to be the colleague with Jeff Hinton, who founded Google's AI lab in the year 2012. Dr. Yu came back to China from AEC Lab, and he was in Baidu. He founded the Baidu's first, China's first IDL in Baidu. And he initiated the first autonomous driving product in China, also at Baidu. And he left Baidu in 2015, obviously, to start this company. And the vision he has really, he's more focused on algorithm and software. By the time he was in Baidu, he realized the algorithm is very powerful and evolving though, but the search volume in Baidu has been so large, and the latency requirement has been so high, so that even you accumulate all the GPUs, all the calculation unit in China, computing unit in China, it does not give you enough power to have that result delivered. So the only possible way is to have your own hardware that is designed and deeply integrated with your software in order to achieve that goal. And that is basically essentially the key concept for autonomous driving as well. For any situation with very high requirement on algorithm and latency. Centering him, we have a team of software expert, starting from the left, Dr. Huang Qiang, also from Baidu, Dr. Wu, our CTO from Facebook, as well as hardware experts from Huawei, Mr. Zhou. He used to tape out the first H.265 chips in the world, as well as Mr. Fang from Nokia, focusing on hardware. So we see a healthy combination of hardware and software expert. We consider commercialization equally important as R&D for obvious reasons. We have accumulated OEM clients across the world, from EU to US, from China to Japan, as well as the safe city and safe city and smart retail customers, as we commercialize our AI chips embedded into cameras, into shopping malls and the smart city projects. Selected investors on the right hand side, we have accumulated a very close relationship with those investors who also we have nearly 20 investors as of today, and we're in the process of B round financing. Just quickly scanning through some of our products. Turning it from PPT to products. The camera you see on the right, on the left hand side is the ones with powered by Horizon Robotic chips. It can achieve a much higher performance in terms of speed, i.e., 30 frames per second versus 12 frames per second, and within each frame, the power of algorithm and the chips enable us to detect and process over 200 objects simultaneously, versus 30 objects in a prevailing products that exist in the market within each frame. And we are able to achieve the camera is able to achieve that result with a much lower power consumption, i.e., lower than 2.5 watt versus 20 watt. So basically, the whole camera can be powered by OPE without additional wire. At the same time, for smart retail, we embedded our processors into the edge of the camera. In that way, versus traditional smart city retail solutions, obviously the bandwidth, the broadband cost, and the cloud computing requirement has been significantly reduced by 10 times. So the OEM cost of deployment has been significantly improved. Also in the autonomous driving, which is one of our most important market, versus prevailing products and solutions in the market, where our solution enables a higher definition video processing at a higher speed, doubles the closest rival, with still very low power consumption, lower than 2 watt in our first generation. And this is a L2, L3 eligible processor. And also the algorithm enables more categorization and calibration, and it can be more adaptive to China's road condition. smart driving software, hardware layer. These are the R&D roadmap. So we're talking about L1, R2 to L3 architecture, basically Gauss architecture on the left. And then now I'm leading you to the second generation of architecture, which we are in the process of taping out. Basically, this is a prototype on FPGA of our second generation chip, and it is fully integrated in the SoC with one I/O and mono camera. We're able to perform the same. We're able to deliver the same result as a LiDAR. But the only thing you need is here is just a SoC plus camera, which and normally right now a LiDAR costs $70 to $800,000 US. You know, which is even more expensive than a normal car. This has been commercialized with one of the leading robotaxi operator in the US last month. The whole solution took 12 cameras, 8 rooftop and 4 fisheye, delivered within the 3 boards that I've shown. Once this roll out, will be 100 to 1,000 cars, because right now the largest robotaxi operator in the U.S. is Waymo. They only have less than 100 car. The only reason why they're very expensive in valuation though, but the reason that really the barrier they see is really the investment to have a car, to have a road testing car, being enormously expensive due to the cost of LiDAR and the whole system, and we're able to reduce that. A quick glimpse on the smart city solution we provide. This is an 8-lane solution versus 2-lane because we have a higher processing power, and the cars, the plate and the model, and also the color can be easily recognized. Lastly, smart retail, from phase to skeleton. Excuse me for the music. This basically convert offline data that are untraceable to online data, like click, like time spent, like for example the lady who is trying the bag after the detection of our camera. There's the little dot here showing that there's one attempt or 112 for this bag, also for this lady. And then facial recognition, which is more which is very common, and it can be linked with payment, and the whole roadmap and also the heat map can be generated in a real-time manner versus this gives a lot of edge for offline retailers when they compete with online ones. Okay. That's my presentation, and thank you for your time.